Hello, welcome back to chemistry, whatever. So today we're gonna try the limiting reactant. In some cases, it's called the limiting reagent, but you could interchange one. So if you see limiting reagent in a test or exam, you should know that that's the same thing as saying limiting reactant. Okay, so starting off with question one, we are given this balanced chemical equation. Now, what is given is 10 grams of sucrose and 10 grams of oxygen reactant. So first we have to find what is the limiting reagent, otherwise known as limiting reactant. Okay, so first, what I'd like to do is put the mass above the desired substance. So here we have 10 grams of sucrose, so it would be right above where sucrose would be, right here. Then 10 grams of oxygen reacting, so this would be also of oxygen. Okay, so now we're asked to find the limiting reactant. So, in order to do that, we first have to convert these two values into another substance in the equation. So let's say carbon dioxide. So what we do is we first convert one of these to either carbon dioxide or water. In this case, I'm going to do carbon dioxide. So you start with 10 grams of sucrose. Okay. Now, convert this to molar mass, obviously, from the other video. And then the molar mass of this, so it's 12 times 12.01 plus 22 times 1.008 plus 1116. This gives us a molar mass of about 342.3 grams of sucrose. Since we have to put grams here to cancel both of these units out. Now we use mole ratio. So in this case, we don't have to find anything. We're just not asking, we're just finding the limiting reactant. So right here, sometimes they'll ask you to find the number of first find a limiting reactant and then find the actual mass of the given substance that is created after determining the limiting reactant. So here we just use mole ratio. So there's 1 mole of, I'm just gonna write this because it takes a while to write that. And then here we just put 12 moles of carbon dioxide. And now this equals to, just plug it into a calculator. And then you should get, and there's obviously 3 significant figures here, so your answer should input to 3. This gives you 3.51 moles of carbon dioxide formed from 10 grams of sucrose. So that's the first, that's half the step of finding the limiting reactant. Now we just do the exact same steps, but instead of sucrose, we do it with oxygen. So we just convert like how we did up here. So we got 10 grams of oxygen, diatomic oxygen. 1 mole of O2 equals 32.00 grams of O2. Mole ratio, so there's 12 moles over there. for every 12 moles of carbon dioxide. Now, in this case, when the mole ratios are the exact same and it's 1-to-1, sometimes you could just skip this part, but I'm not gonna do that in this video because like it would just look confusing. I just want like the general picture. But when these two are equal, or you could put 1 on each one, and you'll still get the right answer. So now, oh wait. There we go. Okay. Now this equals. So really, only thing you have to input here is 10 divided by 32, since these moles are like just cancel out each other. So obviously cancel out these units as well. Don't forget about that. And then you should get, this is 3 significant figures. Your answer should be in 3 significant figures. So your answer is 3.13 moles of CO2 formed from 10 grams of oxygen. So now we can see that to find the limit reactant, we first convert both of these to the number of moles of another substance in the equation, and then we see that whichever number is greater than that one, that's the excess, but the limiting reactant is the one that forms the least amount of moles from that given mass. So here we compare these two numbers right here, 0.313 and 0.351. We can see that oxygen, when O2 was formed from 10 grams of oxygen towards carbon dioxide, we can see it formed fewer moles than what it was for 10 grams of sucrose. So that means that O2 is the limiting reactant. Okay, that's basically how we find limiting reactant for 2 things. Now, problem 2 is asking us, let me move this here so it could be easier. Okay, so problem 2 is asking us to calculate the number of sodium bromide formula units formed when 50 grams of NBr3 molecules and 57 NaBOH formula units react. So first, this is the same as this problem, but instead of going from grams to moles, you have to go from formula units to moles. So what we do that is what's something called Avogadro's number, in which it states there are 6.022 times 10 to the 23rd moles for each formula unit, whether that is atoms or molecules. So here we're given molecules and formula units for these 2 substances. So we are given this, and we're given this one. So we're given 50 molecules, and then 57 molecules for this one, or formula units. But obviously formula units and molecules are the same thing, so you could, but that would just mess up the units. So and we're asked to find how many formula units are formed when these 2 are combined to make sodium bromide. So then, we find a limiting reactant, so in which case we find the mole of this sodium bromide on each one. So 50 molecules of NBr3. Convert this to moles, in which Avogadro's number, in this case we divide by Avogadro's number. It's really hard to like do this. Okay, now we use mole ratio like in the other video. So there's 2 moles of NBr3 for every 3 moles of sodium bromide. And then this will give you, I should really do this like on paper, but I don't know. I don't feel like doing that. So this should give you, we start with, well, okay, there's one significant figure here, because there's no decimal point between these 2 numbers. These 2 are negligible. Yeah, so your answer should be in 1 significant figure. So in this case, it's 1. Yeah, 1 times 10 to the negative 22 moles of NaBr3 or NaBr. Sorry, I keep like mistaking. So this is how much is made, but it's actually around like 1.24. So that's for NBr3. Now we do it for sodium hydroxide, right? Yeah, hydroxide. So now we get 57 molecule units, or formula units. Hold on. I'm just gonna abbreviate it as FU. Never mind, I'm not doing that. I'm gonna form units. Form U, yeah, not FU. No, that's fine. Okay, so now we do the exact same thing from up here. So we have 1 mole. Wait, hold on. For every 1 mole of NaOH, there's 0.22 times 10 to the 23rd formula units. Now we use mole ratio, so there's 3 moles of NaOH for every 3 moles of NaBr. Now we plug this into a calculator. Your answer should be in two significant figures. And then the answer is 9.5 times 10 to the negative 23rd moles of NaBr. So by looking at this, the smaller number in this instance is 9.5 times 10 to the negative 23rd. Since this exponent is like lower than this one, that means this number is smaller. Thus, the limiting reactant in this instance is NaOH. So now, given that this is the limiting reactant, now it is asking us to find the number of formula units formed when these two are combined. So now we do this thing but in the other way around. So now we're given this number. This is X. So this, now you multiply this by Avogadro's number to get the number of formula units for this amount of moles. And this equals your answer should be in two significant figures. Then finally we end up with 57 formula units of NaBr formed from combining 50 NBr3 molecules with 57 sodium hydroxide formula units. Okay, now to the next problem. Aluminum reacts with chlorine gas to form aluminum chloride via the following reaction. How many grams of aluminum chloride could be produced from 34.0 grams of aluminum and 39.0 grams of chlorine gas? So now, this is like the first problem, but instead of finding just the limiting reactant, we have to find the amount of grams of aluminum chloride produced when 34.0 grams of aluminum react with 39.0 grams of chlorine gas. So the same situation here, we just go from grams of aluminum in this instance to grams of aluminum chloride. So I should probably, give me 1 second. I had to get my periodic table. Okay, so 1 mole of aluminum equals 26.98 grams of aluminum. And then mole ratio, there's 2 and 2. So like I said, when these two are the same mole ratio, we don't really have to write it out. We could just skip it, but in this case, I'm just going to say 1 mole of aluminum, 1 mole of aluminum chloride. Since these two are a 1-to-1 ratio, we can just write it like that instead of 0.2. But I don't think that would like really save any time. You would just have to like skip this part if they're both the same ratio. So now we're trying to find the amount of grams made. So now we convert this to grams of aluminum chloride, in which in this case the molar mass of aluminum chloride is 133.33 moles. Cancel your units. I keep forgetting to cancel them out. Now, plug this into your calculator. And then you should get an answer with 3 significant figures, so it would be 106.68 grams of aluminum chloride formed from 34 grams of aluminum in this volume equation. Now then, we do it with chlorine now. So now we start with 39.0 grams of chlorine gas. Sometimes you'll see this symbol that just means it's gas. So like sometimes it'll be aqueous, solid, liquid. So now do it the same way. Water mass is 35.45 grams of chlorine. Mole ratio, there's 3. Okay, so since these are not a 1-to-1 ratio, we have to write it out. So now there's 3 moles of chlorine for every 2 moles of aluminum chloride. And then now, last step, like on the same equation, we just multiply by the molar mass of aluminum chloride to find the amount of grams made. Now this equals sorry. My whole answer just got deleted for a second. Now this equals 3 significant figures, so this equals 37.8. 97.8 grams of aluminum chloride made from 39.0 grams of chlorine. Now looking at these, the least number is the limiting reactant. So in this case, chlorine is the limiting reactant. So that means this is the axis, this is the actual that is made. So your answer should be 97.8 grams of aluminum chloride, since this is the actual amount that could possibly be used with 39.0 grams of chlorine. This is due to aluminum being the excess reactant in this equation. So this is the actual amount that could possibly be made with 39.0 grams of chlorine.